All right, we're going to work with angle relationships in circles today. If you look at the table that starts these notes, it's really important because it tells you where the vertex of the angle is, and then it describes it and then provides the formula for what you would use given that vertex. So on the first one, this is just a review of our last set of notes saying that if your vertex is at the center of the circle, then whatever the central angle is, the arc will be exactly the same. So if I said that this was 100 degrees, jumped on me. If this arc was 100 degrees, then the angle would be the same. All right, let's scoot down to numbers 1 and 2, which are examples with that type of angle. So on example number 1, you can see that you have a diameter here of GD, and you also have a diameter of FC. So those diameters are going to divide your circle in half, which means that this is a semicircle of 180 degrees, and this is also a semicircle of 180 degrees. I have an arc here, a CD of 50 degrees. That means this central angle is also 50 degrees. Knowing that this is a diameter and that this is a semicircle, we could take 180 degrees, subtract 80, and subtract 50 to get this angle right here, which would be 30. We also could take this angle of 50 degrees and do a vertical angle here because we have two diameters. So we've got two straight lines there, and then we formed vertical angles. So this is 50 degrees, which means the arc is 50 degrees. I could complete the rest of these central angles and the rest of these arcs, but I've already answered the question that was asked here. So this is 50 degrees. All right, let's work on the same thing here on example number 2. We've got TW, which is a diameter, and we've got XU, which is a diameter. So I'm going to take these arcs, and then they will be the central angle measures as well, because my angles all have a vertex at the center. So again, 180 degrees right here. So 180 minus 60 minus 50 makes 70. And then vertical angles, this will also be 70. And then that answers the question that's asked here. So the measure of angle TSU, that central angle, is 70 degrees. Okay, so that's just a review from our previous notes. Now we're going to move that vertex somewhere else within the circle. So the next row in our table says that if your vertex is sitting on the circle, okay, so it's on, so it's called an inscribed angle. It means that your angle is in the circle, but the vertex sits on it. So that's going to be a different formula than the row above with the central angle. This is called an inscribed angle. And what's going to happen here is that whatever the arc's measure is, you will cut it in half in order to get the inscribed angle. So that's what this first formula is saying, is that your inscribed angle will be half of the arc. So if we use the same angle that I used above, and let's say that this arc was 100 degrees, we would take that 100 degrees and we would cut it in half. Half of 100 would make this angle 50 degrees. If you had just been given the arc, or sorry, the angle, and wanting to find the arc, 2 times the angle, so 2 times 50, would give you the arc of 100. So if you have the angle, you double it, find the arc. If you have the arc, you cut it in half to find the angle. So if we move to the back of the notes and we look at examples 3, 4, and 5, they all deal with these inscribed angles. These angles whose vertex is sitting on the circle. So right here, it's moving around on me. On number 3, our angle, I'm going to pause the video and fix this. Okay, all fixed. So the vertex is sitting on the circle, which means that we're going to take the angle and double it. So 2 times the inscribed angle will give us this arc of 80 degrees. And then on number 4, what we have is the arc. So in order to be able to find this angle, the vertex is sitting on the circle. So this inscribed angle will be half of that arc. So 1/2 of 158 gives you 79 degrees as the inscribed angle. All right, and then number 5, you're going to have to do a couple of different things here. Let's start with the angle that's given. So the angle that is given here, this inscribed angle, is 82. So the measure of arc 1 right here would be 2 times 82 degrees, which would be 164 degrees. And then the measure of the other arc, keep in mind that all the way around your circle is going to be 360 degrees. So if the arc that I'm showing right here is 164, that's arc 1. Arc 2 would be 360 minus that 164, which would make arc 2 having a measure of 196 degrees. Okay, so that's all for the inscribed angles. Now we're going to go back to the table on the front and we're going to move that vertex again. So this time we're going to talk about the measure of the angle when the vertex is inside the circle but not at the center. Okay, so this is not a central angle. I know this one looks kind of close, but that is not the center. So what we're looking at here is trying to find an angle when the sides here are going to create this arc. So I'll call this arc 1. And then you know that vertical angles are congruent. So whatever we get for the measure of angle 1 is going to be the same for this angle right here. So that angle also creates an arc, and we call that arc 2. So to find this measure here of angle 1, we'll look at the formula. It says take arc 1 plus arc 2 and divide by 2. So you would add these two arcs together and divide by 2 to find this angle measure. All right, we could do that also if we wanted to look at the arcs on the top and the bottom as opposed to the left and the right. So I could call this arc 1 for this angle. And then knowing that you've got vertical angles that will be congruent, so these two angles will be the same, this would be my arc. All right, so let's try and do that on the back with example number 6. Okay, so on example number 6, we're going to be looking for the measure of angle that's labeled X. So that vertex is inside the circle, but it's not at the center. All right, so what we're going to do then is we're going to take a look at the two arcs that are associated with this angle. So here's the one arc, and then if we use vertical angles, that's the arc of the vertical angle. So those are the two arcs that I want to use. So X will be adding those two arcs together and then dividing by 2. Okay, so if we add those together, we're going to have 86 divided by 2. It means that X is going to be 43 degrees. Okay, on example number 7, if you look at the two arcs that are given, you're given arc that is 115 degrees and you're given an arc that is 57 degrees. Those arcs are actually going to be associated with angle number 2. So we're going to ignore angle 1 for a second and we're going to work on angle 2 first. So the measure of angle 2 will be to take those two arcs and add them together and divide by 2. All right, so make sure if you're putting this all into your calculator at once that you're going to put those in parentheses, because what you should get for the measure of angle 2 is 86 degrees. Okay, so this is 86 degrees. Now, to get the angle next to that, we're going to go way back to our first semester vocabulary. These are a linear pair. So together, these two angles add to 180. So the measure of angle 1 is what happens if you do 180 minus 86 degrees, and you get 94 degrees. All right, let's go back up and look at the last formula for the last type of angle we're going to do. So this one is the easiest to recognize, and that's because your vertex is outside the circle. Okay, so if your vertex is outside the circle, to find that angle measure, you look at the angle that is for the arc that is furthest away from that angle, and you call that arc 1. So in the second triangle, or sorry, second circle, that's arc 1. The arc that is furthest away from that angle. Arc 2 is the one that is closest to the angle. Right? And then what you do is you subtract the arcs and divide by 2. So the arc that is furthest away from the angle will be the bigger arc. That one has to go first so that your angle isn't going to be a negative number. All right, so let's look at example number 8. And you can see this formula at work. So my exterior angle, you can see the vertex is outside. My exterior angle is measure is angle 1. So the measure of angle 1, you'll take the arc that is further away and then subtract the one that is closer. So 80 degrees minus 32 degrees, and then divide by 2. Okay, so again, make sure that that's in parentheses. If you're going to do each part separately, you'd end up with 48 over 2. And the measure of angle 1 would be 24 degrees. Okay, so for the next example, we've got our larger arc for our measure of angle 2, but we need the smaller arc 2. And I don't have it right now. So if I went to try and set up my formula, the measure of angle 2 would be that larger arc of 130. And then I don't know what the measure of arc 1 is yet. But whatever happens when I get that measure, I'm going to have to subtract those and divide by 2. I do have enough information, though, to be able to find the measure of arc 1. Because I know that the distance all the way around my circle, or the measure all the way around my circle, is going to be 360 degrees. So if I'm looking for this measure of arc 1, I'm going to take 360 and I'm going to subtract the other arc that I see. So I'm going to subtract 105, subtract 130, and then I'm going to subtract that 70. And what that's going to leave me with is 55 degrees. So then what I do is take that 55 degrees and substitute it in here. Subtract those two. So 130 minus 55 is going to be 75 degrees. Divided by 2 will be 37.5 degrees for the measure of angle 2. Okay, so that's an exterior angle. I subtracted the arcs and divided by 2. Okay, I'm going to move us down now to examples 10 and 11. These are slightly different because what I'm looking for here is the measure of the arc instead of the measure of the angle. So we're going to look at example number 10 first, of those exterior angles. And we're going to say that the formula is the measure of the angle is arc 1 minus arc 2, all divided by 2. So I know the measure of the angle is 38 degrees. Arc 1 is the arc that is farther away, that's 180 degrees. I don't know the measure of arc 2, but I know I'm supposed to find arc 2. So let me just highlight these two here and substitute them into the formula for you so you can see where they came from. Okay, so my problem is here I need to solve for x, and right now x is being divided by 2. So what I'm going to do is I'm going to multiply both sides by 2 so that I can get rid of this fraction. And then 2 times 38 is going to be a 76. And then my numerator, I'm left with 180 minus x. So I need to solve for x, so I'm going to subtract 80 from both sides. And that'll leave me with negative 104 equals negative x. So I need to get rid of that negative 1, so I'm going to divide by it. And that will give me that my arc is 104. Okay, so the measure of that arc is 104 degrees. So I used that exterior angle formula for the where the vertex was, but then I was solving for an arc instead of solving for the angle. Same thing is going to happen over here on number 11. On number 11, you've got an angle that is inside the circle, but it's not at the center. So that formula is you take the measure of the angle and you do arc 1 plus arc 2 and you divide by 2. So my angle is 47 degrees. My arc 1, sorry, this is my arc 2 is 41 because this one is labeled as 1. So these are the measures that I'm going to use, and then I will come back and talk about angles. So the measure of the angle is 47. Arc 1 I don't know, but arc 2 is 41 degrees. And then that's divided by 2. And then I'm going to do the same thing that I did in example number 10. I need to get rid of this. I'm going to multiply both sides by it to cancel those. 2 times 47 is 94. And then arc 1 plus 41 is left. So subtract 41 from both sides. And we get that 53 degrees is the measure of arc 1. And then you could check your work. You could say 53 plus 41 divided by 2 should get you 47, and you'll know that you did it correctly. And then to find the measure of angle 2, remember these are a linear pair. So that means 180 degrees minus 47 for the angle that's adjacent there will give us 133 degrees. Okay, so those are the 4 angles that we're going to have in relationship to a circle. You've got a central angle, so the vertex is at the center. You've got an inscribed angle where your vertex is on the circle. And then you've got the 2 angles that we just talked about. You've got the exterior angle on number 10, and then you've got the interior angle on number 11. Okay, so go ahead and go on to your homework now. I hope that this made sense to you guys.